Now let us learn how to find the determinant of a matrix. Before this, it is very important to know that we can find determinant only of square matrices. In previous video, I have discussed the types of matrices in which I have discussed the square matrices and rectangular matrices also. So we can find determinant only of a square matrices. Square matrices means 2 cross 2, 3 cross 3, etc. Such type of matrices. Now it is very easy to find the determinant of 2 cross 2 matrices. 1, 2, 3, 1. Multiply these two and then these two. 1 into 1, put minus sign here. 2 into 3, 6. So minus 5. So this is the value of determinant in case of 2 cross 2 matrix. Now for 3 cross 3 matrices, let us know how to find the matrices, the determinant of 3 cross 3 matrices. We can denote the determinant by delta or this sign. These two lines and A is written between them. This is the sign of determinant of A. Now the square matrix is written here. The elements of square matrix 1, 2, 3, 1, 2, 1, 2, 1, 2. The very first step to find the determinant of a matrix is put the signs on the elements. Put the signs on the elements. And the very first sign is on the first element is plus. Always put always plus on the first element. Here the first element of a matrix is 1. So we will put plus sign here. Always put plus sign on the first element. Now next sign will be alternate. For example, here plus, then minus, plus. Here plus, then minus, plus. Minus, plus, minus, plus, minus, plus. So you put circle so that confusion, it is just to avoid the confusion. So put circles. So these signs are not with these numbers. Okay, these signs are not with these numbers. These numbers are having positive signs. Okay, all are positive. These, so I have put circles so that you cannot so that confusions cannot be created. Okay, so plus, minus, plus, minus, plus, minus, plus, minus, plus. Now let's as we know that this is row, these are rows, the horizontal lines, and the vertical are columns. So this is row 1, R1, this is row 2, and this is row 3. This is column 1, this is column 2, and this is column 3. We can find or we can expand the matrix by row 1, by row 2, or by row 3, or by C1, by C2, by C3. And the determinant, we know that the value of determinant is always unique. Means if you calculate the determinant by row 1, the same value we will be getting if we'll expand this matrix by C1 or C2 or C3. Now let's know how to find the determinant by expanding row 1. So first of all, if we are taking row 1, so we will take the elements of row 1. Here 1, the sign is positive, plus 1. Now hide these and these, the elements row and the elements column. So this is the where the element is, it is in the column 1 and it is in the row 1. So I have hide. So now the left elements are 2, 1, 1, 2. So write 2, 1, 1, 2. Similarly, minus 2, hide this column, this and this row, first row and second column. So the left elements are 1, 1, 2, 2. So next the sign is minus, so I have put minus here. Then now the sign is plus, plus 3. The third column and first row, the left element are 1 2 2 1. So now let us calculate, as we have learnt earlier that how to find the determinant of 2 cross 2 matrices. Now these are 2 cross 2 matrices, so we'll multiply 2 by 2, that is 4. We'll put sign of minus here, and 1 into 1 1. Again 2 into 1 2, 2 into 1 2, 2 minus 2. 1 into 1 minus 2 into 2 4. So 4 minus 1 3, minus 2 into 0 plus 3 into 1 minus 4 minus 3. So 3, this is 0. 3 into minus 3 minus 9. The answer is minus 6. Now let us check if we find the determinant by C1, is value the same? So now we can find determinant by expanding any row or any column. Now we'll find the determinant by column 1. So determinant by expanding column 1. So the elements of column 1 are this, this and this. So first element is plus 1, plus 1. Now hide the first column and first row, 2 1 1 2. Now second element is 1. So second row, first column, 2 3 1 2, 2 3 1 2. And now third element, third row, first column. So 2 3 2 1, 2 3 2 1. Again we'll calculate the sign, plus 1 plus 1, minus sign here, minus here, plus sign here, plus 2. So now we'll again calculate the 2 cross 2 matrices determinant. 2 into 2 4, 1 into 1 1, 4 minus 1. 2 into 2 4, 1 into 3 minus 3. 2 into 1 minus 3 into 2 6. So here is 3 minus, here is 1 and minus 8. So again the value is minus 6. So now here, this is the way how we can find the determinant, and which is very very simple. Now let's discuss how to write a symmetric and skew symmetric matrix very easily. It is very, sometimes we get confused whether while now I have written this without calculating A transpose, can I check whether it is a symmetric matrix or skew symmetric? So I will tell you how to write a symmetric or skew symmetric matrix in one step. Write any element 1 2 5 as I have written here. Diagonal elements, write diagonal elements first. Now I am telling you how to write a symmetric matrix. This is the first element. Now put 1, any element. I have put 1, you can put any one, any element, 2 3 4. Here diagonal elements, first of all write the diagonal elements as I have written 1 2 5. Now put 1 here, then put 1 here. Put 3 here, put 3 here. Put 4 here, put 4 here. Now this matrix is symmetric always. In this way you can write, or you can judge also. Just hide these elements and check whether these opposite elements are same or not. This is the definition of symmetric also. These are the images of each other. 1 1 3 3 4 4. Right? So hide the diagonal elements and check whether the matrix is symmetric or not. So this is a symmetric matrix, and in this way we can write very easily the symmetric matrix. Similarly, I have written, now if you want to check whether this is symmetric or not in the very first view, so you hide these elements, check 1 1 4 4 5 5. Yes, this is a symmetric matrix. Or the second way is find the A transpose, and if A transpose is equal to A, then the matrix is symmetric. So A transpose means rows becomes column and column become rows. So we change, first row will become first column 1 1 4, 1 2 5, 1 2 5, 4 5 3, 4 5 3. Now this is also again a matrix, so A is symmetric. So in this way you can also find out A transpose is equal to A, it is a symmetric matrix. But this is the very easy method to write the symmetric matrix. Just write the diagonal elements and write the elements in the opposite direction equal 1 1 3 3 4 4. Now I will tell you how to write the skew symmetric matrix. It is also very simple. Write the diagonal elements 0. So diagonal elements of a skew symmetric matrix is always 0. Now write any 3 elements here, 1 2 3. Okay. Now again write same elements here, 1 2 and 3. So you will say it is a symmetric, but not. You put sign of negative here. Now check that we know that definition of skew symmetric matrix is A transpose is equal to minus A. A transpose is equal to minus A. Now find A transpose. A transpose, if you will find, the rows will change into columns. So first row is 0 1 2. Now second is minus 1 0 3, minus 2 minus 3 and 0. So if we will multiply this whole matrix by minus sign, or if we'll take common minus, now we have multiplied this matrix by minus sign. So if you 0 minus 1 minus 2 1 0 minus 3 2 3 0. Okay, now multiply this, you'll get 0 1 2 0 1 2 minus 1 0 3 2 minus 2 minus 3 and 0. So after multiplying with minus sign, you have got A. So A transpose is equal to minus A. So in this way you can write any skew symmetric matrix. Write any skew symmetric matrix. First put 0 0 0, minus 1 minus 2 minus 3, suppose. So multiply this by minus 1, it will become 1. Minus 2 will multiply by minus, it will become 2. Minus 3 will be multiplied by minus, it will become 3. So this is skew symmetric matrix. You can check A transpose will be minus A always.